Hi guys, welcome to the Intro to the Atom. To get us started with our chemistry unit, we have to learn some basic skills that are going to be really useful to us later on when we're trying to understand why things happen. It helps to just know how to do things before you start wondering why you're doing them. Now, some students find this a little disconcerting because they like to know why am I doing this? What exactly does this mean? And I get that, and I promise I will get into the details of why we do things the way we do. But before we can do that, we really need to just not necessarily memorize, but learn certain skills that help us be able to understand the more complex things later. So for right now, what we want to do is just get practice doing simple things that we're going to need to do all the time when we get in the real game. It's like practicing your layups in order to make yourself better at actually being a basketball player, right? A layup is just one small part of the game. You have to understand a lot more than just the ability to do layups in order to be good at basketball. But practicing just layups can help you become really good at those, and that'll free up lots of space in your brain for other things that you need to do. So this tutorial is going to focus in on two important skills that are both actually quite easy, but you have to master them before you move on. One is being able to recognize and use the symbols that come with the periodic table. So each element on the periodic table has its own symbol. You don't need to memorize them because you'll always have the table available to you to look them up, but you need to get familiar enough with them that they don't freak you out when you see them. Then you need to determine the number of protons, neutrons, and electrons that an atom has by using the periodic table. This is also very easy to do once you learn where everything is, but it takes practice before you get good and fast with it. So let's get started. This is a picture I took, a screenshot that I took after I typed into Google Images atomic structure. And you can see that different people show what an atom looks like using different methods and different strategies. I'm going to give you a strategy that looks a little bit like the ones that are looking like sort of orbiting planets around a central location. And it doesn't really matter what system you use for drawing atoms as long as you find it useful for your purposes. It's like it doesn't matter if you're using a map or a globe, it just kind of depends what works for the situation you're in. So these are different models of the atom, but notice what they all have in common. They are all made up of mostly empty space with these smaller circles making up the rest of the atom. There's three particles that make up an atom, and you can sort of look at, let's hone in on this picture here, right? This is a good example. You've got what look like rings, little black rings, right? And on those black rings, you have these green particles called electrons, and they have a negative charge. And then in the center of the atom, what we call the nucleus. The word nucleus, by the way, just means center or middle. It actually is Greek for, I think it's Greek for little kernel or little nut. So the center of the atom, which is called the nucleus, contains two types of particles, the blue and the red, and the blue ones are called protons, and the red ones are called neutrons. Now, for right now, all you need to know is there are three particles called subatomic particles that make up an atom. Subatomic. Sub means below, or in this case, sort of less than, smaller than. So the atom itself is like mostly empty space with these three particles making up the atom. And this isn't even really doing it justice, because if I were to blow an atom up and make it as large as, say, a football field, this part, the nucleus, would be about the size of a quarter. The entire stadium would be empty except for the way outer seats, which is where these little electrons would be, and they would be like the size of little gnats. So this isn't even really drawn to scale. But the idea is there's a lot of empty space in the atom, and it has these three particles. For right now, we don't need to know why or exactly any details about them. All you need to know is electron, proton, neutron, and I'm going to teach you how to find out how any atom on the periodic table, you can figure out what number of electrons, protons, or neutrons that particular atom happens to have. In order to do this next skill, what we have to do is have a periodic table. And I'm going to use this one. It's available online. It's called ptable.com is the name of the website, and it's interactive, and I will show you in class some of the interesting features of it. And I will also discuss with you other options if you happen to not like this version of the periodic table. However, this is the one that I am going to use in my tutorials, so it's probably best if you get used to it. Okay, so I need to blow up this periodic table a little bit in a minute, but before I do, I just want to point out how it is arranged. You'll notice that across the top, there are these numbers, and those numbers across the top number what are called groups. And that's the columns. So you have the first column, the second column, the third column, and so on, and those are the groups on the periodic table. You also have rows that are numbered. So you have the first row, the second row, the third row, and so on. And rows are called periods. So each period is from the left to the right across a row. You'll notice some of the rows are actually kind of short. So like hydrogen and helium are in a row together, even though they're separated by a lot of space. And that space you'll understand that space later on. So they're together in the first period, but hydrogen is in group 1, helium's in group 18. The other thing that you're going to notice is that hydrogen and helium both begin with the letter H, and because of that, their symbols couldn't both be capital H. Hydrogen is just the plain H, and helium is the H with the lowercase e next to it. It's really important that you realize that if an element has 2 letters as its symbol, the second letter must be a lowercase. You cannot write capital H, capital E. That will mess you up. Do not do that. Make sure you get that straight right away. Okay, so far we've figured out these things. We know that the periodic table is arranged into both columns and rows. We call the columns groups going down, up and down, and we call the rows periods going across. Now, there's a repeating pattern on the periodic table that is just like the repeating pattern on a calendar. You go Monday through Friday for each week. So Monday through Friday is a period of 1 week, and then you start over again with Monday. You're going to see that there's a pattern to the periodic table and that it's arranged this way on purpose, but you're not ready for that information yet. So in general, when we look at the periodic table, what we're really interested in is the information that's found in a particular box. So let's zero in and look at a particular box on the periodic table. Let's look at hydrogen right here. Next to hydrogen is the key for this particular periodic table. Whatever table you use will have a key that tells you how the box is arranged. So here are the 4 pieces of information that the box is giving you. It's telling you the atomic number, which is the big number that is written in the upper left-hand corner. Underneath that, the atomic number is the symbol, and underneath that is the name. And then it's giving you the mass of that atom. And the units for this are atomic mass units, not grams. So it's not like hydrogen has, a single hydrogen atom has a mass of 1 gram. That's not true at all. A single hydrogen atom has a mass that is so tiny that I would be saying zeros for a couple of minutes before I'd get to a number. I'd be like 0.00000000000, and then eventually I'd get to a number, and then I get to say the word grams. So atoms are really, 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 really light and tiny, and as a result, we had to give them their own unit so that we didn't have to write all those zeros or fool around with scientific notation. So the hydrogen atom has an atomic mass of 1.00794 atomic mass units, but they don't bother to write the units because the periodic table's kind of crowded, right? So now, what are these numbers useful for? Well, your atomic number is a very powerful number because it tells you what atom you have and how many protons you have in that atom. The number of protons in hydrogen is 1, and I know that because hydrogen's atomic number is 1. Likewise, lithium, who's underneath him right here, his atomic number is 3. That means he has 3 protons. What atom you are is defined by the number of protons you have. That's the only thing you need to know in order to know, hey, what atom is this? Well, how many protons does he have? Oh, he has 11? I guess he must be sodium. Incidentally, notice that sodium's symbol, which you feel like should be S, is not S, it's Na. That's because sulfur was already taking up the S, and we could have, I suppose, done SO for sodium. That would have made sense. But because sodium is such an ancient element that was discovered so long ago, we went back to the Latin name for sodium, which is nastrium. This happens every once in a while. Don't let it throw you off. Just because the symbol isn't what you think it should be doesn't mean that it doesn't match the element. You don't have to memorize the elements and their symbols. You will always have a periodic table to look them up. And after a while, you'll just get used to it. You won't even think about the fact that sodium is Na. It'll just make sense to you. So you can find out how many protons you have by looking at the atomic number. That's this number up here. So how many protons does, say, magnesium have? That's right, he has 12 protons. That's very easy, right? And it's equally easy to find the number of electrons, because guess what? Protons and electrons in a regular atom, as long as the atom hasn't undergone any special things, nothing's happened to it, as long as it's just in its normal ordinary state, it should have equal numbers of protons and electrons. So therefore, if you know the atomic number, you know how many protons you've got and how many electrons you've got. So for example, beryllium, right here, has how many protons and how many electrons? You got it, 4. And I know all that just by looking at the atomic number. Easy, right? So what about neutrons? Well, to figure out how many neutrons you have in an atom, you actually have to do a tiny little itty-bitty bit of math, but it's easy math. Here's the formula for figuring out the number of neutrons. The number of neutrons is equal to your rounded mass, got to round it to a whole number, minus the atomic number. By the way, if you don't know this, hashtag, back before it became a symbol for social media, used to mean number. That's what that symbol means. So if we want to know how many neutrons we have, we're going to round the mass that's given to us to the nearest whole number and then subtract our atomic number. So let's try this with hydrogen. Hydrogen has a mass of 1.00794. If I had to round that to a whole number, I would just round it to 1, right? Because the number following the decimal is a 0, so we're done. We're just going to round down. So the rounded mass for hydrogen is 1, and the atomic number is also 1, so 1 minus 1 equals 0. So that must mean that hydrogen has no neutrons, and that in fact is true. See if you can do this for lithium. How many neutrons do you think lithium has? You can pause. Okay, if you did this properly, you should have found that lithium has 4 neutrons. Here's how you get that. Take this atomic mass, hopefully you could see that that's a 6.941, round that to a 7, subtract the 3, and ta-da, 4 neutrons. It really doesn't get any easier than this. So you should be able to use the periodic table to find the number of protons, the number of neutrons, the number of electrons, and the atomic symbol, and you should be able to recognize the terms atomic number and atomic mass. So I should be able to ask you, for example, for any atom, what's the atomic number? What's the number of protons? How many electrons does it have? What mass does it have? What's its symbol? And so on. And as long as you can do all of that, then you will be able to move on very easily to the next step, which will be drawing atoms. Okay guys, we'll practice in class. See you then.